Okay, now we're going to start talking about the mainframe and how to get around on the mainframe. And when we say the mainframe, mainly we are talking about this, which is called ISPF, which stands for Interactive Screen Programming Facility. You will also hear it called screens because this is the way we get around. It's kind of like an operating system, kind of like DOS, kind of like Unix, but not really. But it will get very easy to work with once you see. Now, the idea is we start out at screens, and this is what we call the main screen. So when you log in, you get this. All right. And from here, you go to different screens to do whatever you want to do. So, for example, if I want to, and I'm going to do this one first because it'll have the most things. If I want to look at a bunch of files, all right, I can do it a number of ways, but I'm going to start out with 3. All right, so 3 is saying to use the utilities. Now, normally I would say 4, which is dataset list, but since this is Hercules, we're going to use 4R. All right, uppercase, lowercase don't matter. And now I am going to start with the prefix of Herc04, which is my ID, my user ID. All right, so I hit enter and it lists out all the data sets that start with Herc04. Now, a data set, you'll notice it has Herc04 dot or period, whatever, ISP dot or period, whatever, right? Okay, so these are kind of called nodes of a file name. So Herc04, for instance, this bottom one, right? Let's just take this bottom one. Herc04 is the first node. Test is the second node. Proclib is the third node. Now, each node you can be up to 8 characters. And you can have up to 5 nodes. All right. Now, this will list out all data sets, PDSs, and otherwise, which I will explain in a different video. But if I want to browse this, all right, I can just put a B in front of this, and which is saying browse that job. And this is a PDS, so it has members, which again I'll explain later. Now, if I want to look at one of these members, I put an S, meaning select this member. All right, and this brings up my data set. All right, and you'll notice over here that I am in browse mode. All right, so very simply, that would be one way, and I'll show you another, of browsing a file. When we want to go back or out of something in the mainframe, it is always PF3. All right, PF3 is out, and I go back. And you'll notice that it will say here that it is browsed. Okay, so now conceptually I am at 3.4R and then with the data set. If I go back again, which again is PF3, and I PF3 again, I am really now at 3.4R. All right, from the main screen, I'm at 3.4R. If I go back, PF3, I am now at 3. So from the main screen, if I had just entered 3, I would be here. All right, so this we would say is we are at screen 3. This is the menu of screen 3. If I want to get back to the main menu, I again PF3. And now I'm at the main menu. All right, now I don't want to PF3 from here really unless I want to log off. All right, but now just another way. Remember how we did 3.4R and we said 3 and then we hit enter and then we put 4R and then we hit enter. We can go directly to this screen by saying 3.4R. So instead of having put enter twice, I can do it this way, which is shorter. But what that means is you have to know, and after you work in there, it will be much more obvious. You will just get to know, hey, if I want to look at data sets, it's 3.4R. If I want to browse, it's 1. If edit, it's 2. Utilities is 3, right? And now, just to go another way, now I'm here, which is again at option 3. Suppose I want to go to option 1 off the main screen. All right, off the main screen, option 1 is browse. I can say equal 1, which means conceptually, all right, the equal means start at the main frame, at the main screen, and choose option 1. All right, and I go into browse. All right, and now I am in option 1. If I PF3, I get back to the main menu. So what does this mean? This means as you work with it, you will know how to get to each screen, right? I want to look at job output. Well, I know that's 3.8. All right. Again, I can PF3, go back. All right. So this is how you get around on the mainframe. And it's really just learning and working with it that lets you put these kind of shortcuts into your head. All right. So I am going to now talk about the options you are most likely to use. All right. Again, 3.4R is one of the very biggest. But if I wanted to browse, I could also go into this, which is browse. And what happens is, okay, I have set this up. Remember how I said there's 3 nodes? Well, okay, here's my first, here's my second, here's my third. I did not specify a member, but I'm saying I want to browse. So if I hit enter, it's like saying, okay, yeah, I want to browse, but you haven't given me a member to browse. So if I hit enter, it will list the members. And again, if I browse, I just say S, and I am in browse mode. All right, meaning browse, meaning I cannot change the JCL. I cannot save any changes. And so I can look at it. So I wanted to go out of PF3. Now, if I wanted to do the CMPL0001, right, and I knew which one I wanted to, I could just put all right, and I'm in browse on that member. Okay, so what do you do? Again, generally what you would do is you would make this the PDS that you are most likely to use. All right, so set that up to be what you're most likely to use. You will remember uh, that now. Naming conventions of the members. We're going to talk about PDS a different video, but we might as well say a little bit about it now, which is you have 8 characters to give it a member name. You need to make it logical and reasonable. So, for example, right, I know that this JCL Live is to add a user. Okay. Now, there are different ways, so I'm calling this 1, add user 1. If I want to do it a different way, I might create another member and call it add user 2. The CMPL to me means compile. So this is my first compile. Again, I can compile more than one way. I can set up the JCL more than one way. So I make this compile 2. All right. So, but the point is, when you add these members, you create these members, you give them a member name. So make the member name logical and meaningful. All right. So whether you do CM compile, you can execute, you can sort, you can put a ton of things, but make it so that you can, from those 8 characters, which can have numbers and letters but must start with a letter, that you can figure out what this member is supposed to be for. All right, but this is browse. So option 1, use a lot. Option 2, same thing. Difference is now if I do this, when I go into a member, I am in edit mode, right? The rev edit means I am. So if I make a change, it will get saved. So I'll just make a quick change. Repeat this line so I have an extra one. Now I want to save the changes. If I go up here and say save and hit enter, notice it will say the data saved. Right, I added this so we have 3 comment lines here, and just to show you, once it's saved, I PF3. If I select it again, the changes are saved because I have 3 instead of 2 here. All right. But if you want to edit again, what are you most likely to do? Now, you can override. You say, well, I got a lot of PDSs. I don't want to do it. Well, you can overwrite it by here. The other means, okay, I don't want to do that one in the top half of the screen. I want to do something different. So I'll just say, uh, now this is a PDS. I didn't specify a member. So again, it will give me the member. I can go to S. And again, notice I am in edit mode. All right. So browse and edit are very similar. I put the PDS that I am most likely to use up here, right? One node at a time. Generally this will be blank, and you fill it in if you know it. Otherwise, you leave it blank and you have to select it. This, though, if you put this in something in here, you override and it will look there. So other than that, edit and browse are very similar. All right, PDS, we're going to get to 3, very important. 3 is probably the main menu choice that you are most likely to use. Again, I can go into 4R, list data sets, and from here, right here, I can put a B for browse or E for an edit. So I'll just edit, and again, there's just one here, so I'll select that. And now it doesn't say rev edit, but it says edit. All right, so I'm just going to repeat that, save it, and notice over here it says data saved, right, in IPF3. So again, I could do it in 1 equal 1 or equal 2, or I could do it in 4R. Also, because this is, again, Hercules, we use 4R, but really on most mainframes you would use 4. So pulling up a data set list is really 3.4. All right. Now, you got to go through these one at a time. 1, you are not as likely to use. All right. 1 is a screen that you set up, and once it's all set up, you don't use as much. So we're going to set this up, sys2 jcl Again, there is no point browsing, delete, rename, but we could just show there's different ways to do this also, but let's just take an example of, I'm going to do a copy. The C is, so let's test COBOL, right? So blank, I'm not doing anything. It looks like 3.4R. So let's try and do something. Let's try to, I don't want to delete it. Let's say I want to rename COB0000A to, 1 to COB0000A. All right, I want to do that. And, well, I said R, because if you did it in the 3.4R, you could say R or REN, which B names, but it'll say N. Okay, so rename, and member renamed. All right, so I look at it now, and notice I have COB0000A. All right, I can go 3. I can rename it back to COB0001. My number renamed again, and now I got here, and I got it. All right, now the browse, delete, and rename are all things that can be done from different screens or a different way. So again, do you want to do that now? This is something that on Hercules you have, on the mainframe you used to have, but it might not be on yours anymore. The C, the compress, the idea is it's almost like a defrag on your Windows screen. All right. A data set has a certain space allocation, and it will occasionally get filled up. And the idea is that you can't compress the data set to free up more space. But this is screen one. Again, you set it up. I don't really use it very much because I can do everything else that I want to do a different way. Now, 2, data set information. All right. So this I would use a lot, but let's just do this. All right. When I hit blank, it's data set information. So, for example, it says where this is, what's the organization, okay, PO, physical, I'm not sure what the O is for. Normally it's like PS for physical sequential. The record format is FB, which stands for fixed block. The record length is 80. The block size is 27920, all right? Number extends 1, 645, secondary quantity, remember. Now, directory blocks, if it's anything other than 0, that tells me it's a PDS. All right, but this is my information. Now, that's good. I could have got that from 3.4R by putting an I next to it. But now, let's say I want to create another PDS. And what you do is you bring up one that you want to basically copy the format from. So if I want to create another FB80 to 27920 PDS, I bring up one first, which I just did with HERC04.test.cobol, and I would say A, and I'll say HERC04, which is my ID, dot test.alloc.tst. All right. So what that means is I want to basically create the file herc04.test.alloctst. All right. Now, notice it grabbed the FB8027.920 from the previous data set. This, the volume, I really don't care where we create it. All right. So generally, we leave that blank. All right. The space unit is T for tracks, C for cylinder, B for blocks. Primary space quantity is 45, so I'm allocating 45 tracks. I'll give it a secondary of 5. But now, number of directory blocks is 38. Again, if this were not a PDS, if this were just normal flat file, I would make that 0. Since I want it to be a PDS, I'll leave it as something other than 0. I will enter, and it will say dataset created. And if I were to go to 3.4R, I would see herc04.test.alloctst. All right, so delete again. All right, we can do that. Rename, again, these we can also do different ways. All right, the delete and the rename. Catalog and uncatalog really don't use very much. 3.2, basically that I ever use it for is really for this. Right? This is how you allocate a new data set. All right. 3. So now if I take this, I am at 3.3. So now, all right, the move we don't really do, but 3.3 is basically copy. So if I want to copy, let's say I want to start out a new program, COB 0000A. All right. And I want to copy it from COB00001. All right. I would put copy, C for copy. I'm copying from, notice this is from, right, from here, and I hit enter, and notice it says from here, but now where do I want to copy it to? And I'm going to copy it to member A. All right, and I hit enter, and notice up here it says 140 records copied. And if I were to look in herc04.test.cobol, we would have a member COB0000A. And it would be a copy of COB00001. Very important. We don't write things from scratch, right? We find a program or JCL or PARM or whatever it is that is close to what we want. We copy it from there into our new member, and then we edit it. So 3.3 really is copy. All right, which you can save yourself a lot of time and do a lot. The 4R, we showed you the reset, the hard copy, the disk volume table of contents. Really, we don't care that much about. Now, 8. 8 is very important. Outlist. This shows the results of my job, which in mainframe terms, when you want to run something, you submit a job. All right. And you can see the output of your job, right? You got to see whether it worked or it didn't work. So that goes out here. And if I want to look at that, I can put an S by my job, right? And notice jobs, you tell because they start with job and they have a job number. When you submit a job, you'll get a job number. I do this, and I can PF8, and this is a compile of a program. All right. And it says, oh, sorry, I got an error. This JCL didn't run because the overridden step isn't found in procedure. What does that mean? Well, if you'll notice up here, overridden step. All right, normally we get that to be that you're starting at the wrong step. But 21 and 22, what this means is, see, notice line statement number 21, 22. These go up to 21 and 22, and it says the overridden step is not found. So what that means is in my JCL, I have go, and the step isn't called go. So I have to go back and fix my JCL. But the idea is you see the results of your job in 8. All right. Now, on a normal, big company mainframe, you will normally go to option S, which stands for SDSF, and you go into like S.H for hold, S.I for input, S.H for held, and there's a bunch. But this is very important. It is where you see the result of your job, and you have to see, because you have to see whether it worked, or if it didn't work, what went wrong with it. All right? So 8, very important. 9, we're not going to use very much. Compare data sets. This will be normally of 12 and 13. You use 13. And really what this does is and I'll show it later, but I put in an old data set and a new data set, and it compares them. It goes line by line, character by character, and says, oh, is there any differences? And why is this important? Why is this a good thing to know? Because let's say was changing a program, right? And I ran the production program and I ran my test program with the same input, and I did not expect any changes, right? Yes, my test program should be different from my prod program, but with this data, it shouldn't have made any difference. Well, then I can compare the output data sets, and they better be exactly the same. Conversely, if I run my test program and my prod program and I'm expecting changes, well, yeah, there better be some difference in here. All right. So in proving your changes worked, this is a very important screen. There is also a batch job version of this. Dataset copy, again, I can do that in 3.3. Different, like in where I work at our mainframe, we have this written C list called dupe, D-U-P, which allows you to copy it. So the DUC, not really going to use very much. But that's 3. Option 3, the utility. Also, remember that this is not completely standard. Your place may have other options. All right. The language processors, you really don't use. I know it's very tempting to say, oh, we have an assembler compiler, we have this compiler, we have Fortran, we have all this. I want to write stuff in there and compile it, and we're going to do it kind of like a Unix or a DOS, and compile and run commands and not use the JSL, etc. But really, you're not going to do that. All right. Now, 6. Entity. This is a very good one to know. And what do you use this for? Okay. I can do things like delete. So I can say TSO now. This file does not exist, but I'm just showing you this, that I can go, the TSO means, okay, this is a TSO command. The DEL is short for delete, and I'm saying I want to delete this file. But it says, oh, it's not deleted because I can't find it. All right. But there are certain commands you can run. You can do the TSO commands. You can run a CList. You can run a rex. All of this is done from here. So this is kind of like, okay, I'm bypassing the whole screen part of it, and I'm just going to run a TSO command by itself. Another thing we use this for is to transmit files back and forth between the different LPARs, which against a letter. But the idea is this is a very good screen, and this is common, yes, and used in all mainframes. All right. So the 7th, dialog testing, you don't really do the changes for these, you don't really care. TSO, productivity tools, and handy apps. The tutorials we don't do. Terminate ISPF, exit now. So let's just go into M. Now this might be called, every place that I have been has something like M. It may not be M, it may be E for But what it does is, because it wasn't E, it's M. Okay, so these are different things that your particular system, your particular mainframe has. So off this edit, I may be able to go into DB2, right? I may have a CICS screen programming facility. I may have a file manager. I may have file manager from iOS. I may have, my debugger. I may have, there could be a lot of different things. But these are kind of like utilities and different things that aren't really on the standard ISPF main editor, but still are used and provided by your shop and are very useful. All right. So these, again, you just have to explore. All right. So these are the main options. And once you've done this for a while, it's very much easier. You don't have to remember. You just automatically know. Again, 3.4 and Hercules 3.4R is data set list. Right? One is edit, two is edit, excuse me, one is browse. Right? If I wanted to compare two files, it's 3.13. Right? If I want to do a TSO command, I just go equals 6. All right? But this is how you get around on the mainframe. There isn't really the concept of directories or of directory structure or file structure. There's really kind of like a hierarchical structure of screens. And this is the top, right? I'm at the top level, and choosing any other option, I'm at the next lower level. And from this lower level, I can again go to an even lower level, right? But to go back up, I will go up here 3 until I am back up at the top level, which is my ISPF main screen. So this is a short video on the concept of how you get around in the mainframe. When you're done, I could either PF3, but you can also, and what probably normally you do, say X for exit, and that means you want to log off. Now, I'm here, I can log off, right? That would be one way. Or actually, I should be able to log back on again. And I will get, well, it's TSO. The TSO stands for time sharing option. Because the idea is a mainframe, think about it as a big pool of resources, and there are many, it can be hundreds, maybe thousands of people on the mainframe. And it shares its resources with all the users. I go here, and you will not get this on every, this is peculiar to Hercules, but I log back on, and again, I'm back at the main screen. So this is how you get around. And there will be a lot more videos on this. So hope you learned a lot. And it's really, once you get working with it, it will get very much easier, very conceptual. Just got to get the concept of the top level and going to different levels of screens. So I'll see you on another video. Goodbye.